Recording in progress.
Hello, everyone, and welcome to the 2024 Lord Renwick Memorial Lecture, which is in memory of Harry Renwick, who is a great leader in Parliament on all these subjects. And I'm here to introduce Professor Sir Nigel Shadbolt, who you may or may not know, but he's been around this world for a long time and specialist in AI systems from the start. He's a principal of Jesus College, professorial research fellow in computer science at the University of Oxford. He started off with a first-class honours degree in philosophy and psychology at the University of Newcastle. His postgraduate studies were in the Department of Artificial Intelligence at the University of Edinburgh. Then he went on to join the Department of Psychology at Nottingham, where he established and led the AI research group, and then he became the Alan Standard Professor of Intelligent Systems. Then he moved south to the Southampton School of Electronics and Computer Science, where he led the Web and Internet Science Group. He went on to be appointed, along with Sir Tim Berners-Lee, as Information Advisor to the UK government. This work led to the release of many thousands of public sector data sets as open data, which is a great step forward. Then in 2010, he was appointed by the coalition government to the UK Public Sector Transparency Board, which oversaw the continued release of government open data. He continues to advise government in a number of roles. He's a chairman and co-founder of the Open Data Institute. He's a former president of the British Computer Society, a fellow of both the Royal Academy of Engineering and the British Computer Society. He's researched and published on topics ranging from cognitive psychology to computational neuroscience and artificial intelligence to the semantic web. And finally, he received his knighthood for services to science and engineering. So I'm very much looking forward to hearing what he has to say, and I know that I'll be learning a lot. Anyway, over to you, Nigel. Thank you very much for consenting to do this, and we look forward to hearing what you've got to say.
Thank you very much indeed, and it's a great pleasure to be here with you. I'm just going to bring up the appropriate slide here to share with you, and there we go. Hopefully, people can see the slide now. So yes, great pleasure to be with you. I suppose institutionally, I wear a number of hats, as already been indicated from my professorial role in the University of Oxford in computer science. I am head of house of Jesus College, but also co-founder and executive chair of the Open Data Institute. And these various different roles kind of give me, I think, a variety of different perspectives on how the technology of both AI and the data that supports it is evolving. So today, I want to talk to you about the regulation, governance, and ethics of artificial intelligence. And I frame that as if human in a way that hopefully will become clear as I get into the talk, which should be for about 35 minutes or so. First of all, just to say it is an honor and a privilege to be giving this memorial lecture. Lord Renwick, Harry Renwick, was a remarkable figure. I knew him. I was always impressed by his energy, his touch, all the way back for his involvement in Pitcom, Neurim, and what became, of course, the DPA, a remarkable individual. And I think it is brilliant that we have this memorial lecture in his name. So the topic, as if human. I suppose it's a bit self-serving, perhaps, but just to say that it is the title of a book that's just been released by Yale University Press. My co-author and I, Roger Hampson, use this title, and I'll try and explain why we use it in that way, and to make sense of the world in which we live in terms of precepts and guidelines. I think can all get behind that. Also here in Oxford, I'm involved, helped set up the Institute for Ethics in AI. And I think we're all aware that there is some general need for ethics, regulation and governance in this area. And two of the things we argue for in the book is that decisions that affect a lot of people should involve a lot of people, and that we're not going to be best pleased to find ourselves in a situation where our collective future is being decided in private by a small group of vested interests. So how do we kind of pluralize this discussion? Events like this and the work of DPA and many other organizations is central to this. So first of all, let's just reflect on AI itself. It isn't a new science. Turing's own work, Alan Turing's own work in the 40s and 50s prefigured artificial intelligence. Turing, of course, this extraordinary mind, laid the foundations for computer science itself. His paper in the 1930s on computability, the basis of what we call Turing machines. Then his work during the war, Bletchley Park, developing systems to break the German ciphers. And then after that, his work at the University of Manchester, where in 1950, he published a paper, actually in a philosophy journal, called Computing, Machinery and Intelligence, where he postulated what has come to be known as the Turing test, or the imitation game, he called it, in which even in the 1950s, he foresaw the steady development of computers to the point at which we would be having precisely the conversations we are today about the nature of these systems, where they might exceed certain human capabilities, and what we would do in that circumstance. It was actually in the 1956 conference at Dartmouth that the term artificial intelligence was really coined and used more generally to describe this nascent field. Previously, it had tended to be called in the UK machine intelligence, but artificial intelligence was the term of art that became established in 1956. In other words, this is an almost 70-year-old discipline. And nor are the ethical concerns around computing machinery new. Norbert Wiener, the founder of cybernetics, foresaw the trajectory again that we're on. And even as early as 1948, in his great work, Cybernetics, wrote that it had been long clear to him that ultra-rapid computing machines were in principle a central nervous system for an apparatus for automatic control. And before the advent of the atomic age, it had occurred to him that we were here in the presence, quotes, of another social potentiality of unheard of importance for good and evil. So AI is not new, nor are the ethical concerns. And the other point I want to make at the outset is that AI is not just about machine learning. In fact, it's a large and expanding set of theory, methods, tools, and techniques, a selection of which I've shown in this slide. And it's been pervasive and ubiquitous for decades. We will ask the question of why it has become so much to the fore in recent years, but you can see from that set of methods that this is an expansive tool set. So let's just reflect on one approach, very much the approach that I was introduced to when I first went to do my PhD at Edinburgh in the late 1970s. We called it symbolic AI, and we were about trying to build very often what came to be known as knowledge-based systems or expert systems, systems that were designed to solve a particular task. And they required that you took the expertise, a particular human expertise, represented in a way that you could then enter into machine code as rules and constraints, explicit rules that managed a particular set of knowledge about a domain. On the right there, you can see an early expert system that I was involved with. It would take the diagram at the bottom of the slide, which is actually a process flow sheet for manufacturing a chemical, and turn it into a three-dimensional layout, which you can see in the top right-hand corner there, in 3 dimensions. It was difficult and challenging, taking that human expertise and codifying it. And the thing that we discovered in this process is that a huge amount of human knowledge is implicit or tacit, common sense knowledge. And the challenge of building systems this way to achieve specific tasks like plant layout was very much the engineering of the time. There were always the challenge with these approaches about how you would generalize from one task to another. This approach, though, achieved and has achieved over the years and still continues to achieve considerable success. And one example would be the contribution that symbolic AI has made to the area of mathematics, where actually proofs in mathematics, whether in graph theory or algebra, have been made by these automated systems, so-called automated theorem-proving systems, where very precise application of rules in these specific domains have yielded insights and supported human mathematicians in discovery. But there was always a second approach in AI, so-called sub-symbolic AI, which took a very different view. It modeled behavior as complex patterns without explicitly predefined rules or symbols of the sort that I used in the previous example. It used layered networks of so-called artificial neurons, which learned to recognize patterns and make decisions through exposure to large amounts of data. And those decisions are made through the adjustment of link weights between those nodes. You can see in the top right-hand corner again, a so-called deep neural network with nodes represented as circles, and those straight lines, those links, are the weights that would be adjusted. And by repeated presentation of data, in this case, I'm showing you examples of medical images representing, actually in this case, various forms of skin lesion, human skin lesion. It can learn to adjust those weights so the outputs will be decisions between whether what it's seeing is a malignant or a non-malignant lesion. It uses this using training data, and in the about 2017, papers were starting to appear in the literature that showed the power of this so-called neural network approach to perform at levels that expert human practitioners could perform. Very different style, not explicitly managing rules that you could look at and understand as language rules that had existed in earlier systems, but represented it as network weight adjustment. Now, those networks turn out to be very powerful. They can perform at very high levels, but it's important to say that they were susceptible always from the outset to attack. What we see in this slide on the bottom left-hand side is a famous example developed where a system was trained to do a very good job on recognizing what objects it was seeing, whether the soap bubble or the peacock feathers, the peacock there in the image. What this work did was one network was trained to recognize these images, and another network was trained to develop images which could fool the first network to misclassify. And the two images just above the labels bubble and peacock, which look like random colored noise to us, were actually generated by another neural network to fool the first network into making a misclassification. In fact, to make the misclassification with 99% confidence. And this kind of fragility reveals a couple of things. One is that what is being represented inside these neural networks need not necessarily correspond in any way at all to the kind of image breakdowns we imagine we see when we're classifying bubbles and peacocks. And it also suggests that there are ways to defeat systems. So a famous way of defeating neural networks is to develop various patches which you can attach to all sorts of objects, t-shirts, or indeed road signs, to get predictive neural networks to misclassify. So the example there on the right is a famous example of a patch that's been applied to stop signs, and suddenly the system is misclassifying the stop to a speed limit of 80. Again, developed using these adversarial methods. So it's just to make the point that powerful though these networks are, they are susceptible to attack, and there's an issue about how we make these systems resilient. Now, the years since we began to look at these systems have seen a huge rise and explosion of different kinds of neural network architectures. Lots of increasing innovation, different shapes to these networks, increasing amounts of computer power being thrown at them. And suddenly we're introduced to the emergence of generative AI, systems that are able to apparently produce extensive coherent, coordinated text. And I think what's really brought many people's attention to the field of AI has been the fact that these systems, the chat GPTs that we interact with, appear to be conversationally coherent. These are neural networks that are trained on large amounts of data, and their entire objective is to learn to predict the next most likely token in a sequence. You might say that they're unreasonably effective in this task. In fact, the example on the right there is an early version of an answer to an All Souls Oxford College examination question, what is Kant's view of judgment? And out comes a coherent and well-grounded answer. These systems are trained on huge amounts of data, pre-trained with sets of effectively encodings and weights that allow them to have a powerful model to anticipate the next token in any string. And the ChatGPT, or the so-called large language models we now hear so much about, are effectively these powerful systems to anticipate the next token in a sequence. And there's been an explosion of techniques and methods in very recent years of these types of systems. I'll just give you a little bit of an evolutionary tree, and you'll perhaps see there some systems you've heard of, from Llama to Bard to Palm to ChatGPT, GPT-3, and so on. The actual origin of these systems goes quite a long way back as you look into the history of these methods and techniques. What really spooked the field, though, was evidence that these systems seemed to be getting more effective the larger they became. The more data they had seen, the larger these networks, the more capable they became. And they started to pass any number of professional exams and qualifications. And suddenly we're in a world in which people could seriously look at systems and say, these systems appear to have passed effectively Turing tests of various sort. You could not know from looking at the output whether this was a person or an AI system that had generated the response. And these systems are being used in science, not just in text generation, famously in various areas where if you're trying to predict the next most likely token in a sequence, you can represent a lot of problems in, for example, drug discovery or life science analysis in just this way. Demis Hassabis's DeepMind has worked extensively on systems like this. The other thing that became apparent early on is that these systems are not just powerful in generating novel and interesting content, they can generate content which in some sense is fraudulent. AI able to boost scientific productivity on the one hand, but also produced entirely fake content. So papers started to emerge as soon as these large language models emerged around fakes of various sorts. How do you detect plagiarism? How do you detect a request made to a system to generate an entire scientific paper, which I asked here, you can see me prompting, write me a short research paper which includes an introduction, methods, results, and conclusions section comparing the effectiveness of two drugs using a set of data assets. And the study is manufactured. It's never been actually executed. It's been manufactured by the system. So we also find that AI is also being used in this dual use fashion, not just to generate fraud, but also to detect fraud. There's an arms race, in other words, between AI use for good and AI being misappropriated. And that brings us to the whole issue about what is governance and regulation to do in the face of these rapid developments. I think we can look at what's happening literally in the last months as a variety of different responses. Clearly, individual nation states have taken a particular view on how they're going to respond, especially in the US and also the UK and the EU states and China. We're seeing various regulatory regimes, various proposals emerge on what might be done to govern and regulate these powerful new AI systems. The White House produced recently an AI Bill of Rights. The UK set up the AI Safety Institute. And indeed, bilaterally, both the US and the UK have agreed to share insights. The UK-US AI Safety Institutes are collaborating. The EU has its Artificial Intelligence Act. And literally today in Seoul, in South Korea, there is the second meeting, the first of which was the Bletchley Park Summit, co-hosted by the UK and South Korean government in Seoul over the next 2 days, looking at progress for understanding how we might respond to the safety issues raised by these AI systems. And in fact, Yoshio Bengio, who chaired the coming together of this report, the International Scientific Report on the Safety of Advanced AI, it's a very balanced, I think, and thoughtful approach to how we make progress. So individual, bilateral, and multilateral initiatives. And indeed, if you trace that history, you can see just how active it is. There is a lot going on in this space, and there's a lot for us to be aware of. Stretching right back to the European Union's GDPR regulation. Earlier still, China published its new generation artificial intelligence development plan. And through that, right up until the most recent developments, and we can foresee in June of this year, the EU AI Act actually enters into force. In July, the UK consumer duty comes into effect in particular sectors, which will impose an interesting obligation on our regulators. So this is an active area of government interest, and approaches differ. This is the European Union's approach, which seeks to triage different sorts of AI system from minimal risk through to systems that pose unacceptable levels of risk. Different articles of the EU Act apply to that. They're trying to anticipate those systems which demand much more scrutiny. But there are different approaches. The pro-innovation approach that the UK is adopting is going to rely extensively on regulators. So if we think about the regulatory landscape, what are we to make of how that's evolving? I think it's fair to say that the regulatory landscape varies substantially by jurisdiction. And it's also fair to say that to a very large extent at the moment, the most powerful actors in this modern AI space are US tech platforms. They dominate, whether it's Google or Microsoft, Meta or Amazon Web Services. There are significant differences between the powers that regulators have. So in the US, the Federal Trade Commission has particular powers around deceptive and discriminatory practices. It can actually levy fines directly against organizations that are seen to infringe those particular protections around individual consumers. And here in the UK, we're beginning to stand up our regulators with new powers and responsibilities. So the Competition and Markets Authority, for example, is being given substantial regulatory oversight of challenges around market concentration, whether or not individual players in this space will have overly powerful influence. Regulators have differing powers. The competition authority in the EU is also a player in all of this. And all of them face the challenge of expert staffing. This is an area that demands expertise. They are competing for resources in a very scarce talent pool. And we're going to be, I think, really seeing the challenge of regulators staying current with and trying to invent new ways to recruit expert opinion that they can use in making their regulatory judgments as they apply to the, for example, large platforms. And it's important, again, to recognize that even these most powerful of modern AI generative systems make mistakes. They can have outdated facts. They can fail in particular reasoning contexts. They famously hallucinate or confabulate. That is, they make things up because at their essence, they are predicting the next most likely word in a sequence. And in some cases, that plausible sequence may never have existed in the real world. And the very best systems at the moment, for example, in a task such as summarization, hallucinate about 3% of their content. Now, that may sound not too bad until you think about how you identify that 3% of content in your 800 summarized documents that are material to a decision you might be wanting to take. There are challenges, in other words, about how these systems are held accountable, validated, and verified. And I want to close out on considering the obverse side of the AI challenge. Yes, the algorithms are various and different. We've talked about different sorts, from neural networks to symbolic rule-based systems. All of them depend on high-quality data. It really is the garbage in, garbage out principle. We at the Open Data Institute would always argue that a foundation platform for many of these systems is open data, and ideally high-quality open data. If you just look at the amount of content that the big large language models ingest, it's a substantial amount of the published content on the web. So data, good, bad, and indifferent, will have been ingested. It's important that we have an appreciation that data is an infrastructure, that data has to be thought of as an assured product. It simply doesn't emerge into the world as necessarily verified and validated itself. And that it, in its own right, as we understand with issues such as the fair use of data, has its own ethics, governance, and regulatory requirements. And data isn't of one stripe. Whilst there is open data, there are shared and closed versions of data. And in any data ecosystem, we will have different types of data rubbing up against one another. And the rules and stipulations in one may not read across into another. And we are seeing this, of course, in the various litigations and complaints that are being made by owners of data who feel their data has been appropriated into these trained AI systems without appropriate reference, permission, or remuneration. And perhaps finally, just to think about the fact that increasingly the data in an generative AI world is, well, AI generated. And various estimates to what proportion of the data on the web is machine generated vary, but it's becoming more and more significant. And a very interesting recent observation has been the risk of what's called model collapse. It's the fact that if systems are trained only on machine generated data, they tend to, well, many things can happen. One thing that can happen is they can regress to the mean. So if you are feeding data from one AI model into another AI model, and that model then generates more data, what you tend to see is this regression to the mean in terms of many of the distributional features of that data. Models start forgetting improbable events over time. It becomes poisoned by its own sense of how the world looks like. So it turns out it's going to be very important to be able to sample naturally occurring data in the world of AI learning systems. So back to this issue, the foundational importance of data. That we may need to think about new ways in which that data is generated, managed, assured, and reused. Interestingly, This was the theme of our recent AI summit. Without data, there is no AI, and without good data, there's no good AI. We talk again at the ODI about new institutional arrangements for managing data, so-called data trusts or data institutions. A very recent paper from the Tony Blair Institute talks about the idea of being able to use data that is corralled explicitly and managed for particular sectors such as health. And again, just happens to be the very same week the Tony Blair Institute has just published a paper on how AI itself might transform government. Now, this is an old idea. The fact that we could take the latest technologies and try and improve the process of government itself, whether that's from evidence-based policy to improvements in efficiency to improvements in decision-making. And the principles in here are interesting. It's definitely worth a look. And with the cycle of political electioneering we're in, it's likely that the competition between different parts of our polity around ways in which AI can be managed, exploited, used, and referenced is going to be a very significant one. So I'd just like to close out on some of the ideas that we were advancing in the book, As If Human. The as if human here is not to say that our AI systems now and in the future are in any sense self-aware or sentient. I absolutely think that is not the case and not in prospect. They have impressive capabilities, and as such, as they intrude in our lives, a very useful working heuristic is to hold them to account as if they were, because over the last 2,000 years, we developed a set of moral precepts and rules for engagement about how we hold one another to account. And it's interesting to reflect on what they are. One of the most fundamental things we expect to manage effective and truthful interactions and discourse is to not have widespread dissemblings. Not to say that humans don't, but the principle that a thing should say what it is and be what it says is exactly a fundamental principle that is being violated in the case of deep fakes. That actually you're being led to believe that something you're seeing is the truth when it absolutely isn't, or that you're invited when you're interacting with a chatbot to think this might be a human on the other end. It's not that we imagine that putting this stipulation out there means that everybody starts to behave, but rather that those who are using AI ethically would always have this as a fundamental design precept. That when we build our AI systems, we try and design them to have respect for human beings. What does a respectful interface look like? Well, we kind of know when we are using systems where, in fact, the entire design rationale is to almost promote a form of polarization, a form of outrage, a form of engagement of your attention, which is less than respectful. And that if we think about designing systems which embody the best of values, that respect our autonomy, our attention, our time, don't try to harvest it in some unthinking way, we might end up building better, more effective systems that empower humans rather than oppress them. AI should be transparent and accountable to humans. I think there's an increasing sense that we also need to give ourselves redress, to have decisions judged by humans if we so wish. And the final two points that I started this talk with is that in this dialogue, in this discourse, we absolutely have to have a plurality of perspectives. Lots of people need to be engaged in this discussion, whether it's the citizen jury model, whether it is citizen assemblies, whether it is the kind of thing that academies can lead on, or indeed groups such as this, the representatives in our parliaments, the people on our civic society boards, the people who are educating the future users of this technology, need to be thinking and involved in this decision about how the technology is going to be deployed. Not that it is the sole preserve of a particular subset of owners, directors, and managers of a very few powerful technology platforms. Thank you very much. I think I've stopped sharing.
You have.
Somebody is going to moderate. I think that was about, that was probably a bit longer than 30 minutes. I apologize, about 35, 40. My apologies.
It was
Nigel,
brilliant.
I think I understood about 5% of that. Let me just try and ask one or two questions while people are thinking. We've got two in the chat box waiting. So you really are saying this is kind of 10 commandments. It doesn't have to be 10, but we need to agree some rules quite quickly. Now, the question there is, you wouldn't go to the United Nations. When we had stamps and we had telegrams, we finally had the IPU and the ITU, or the IPA, I think it was. Are you suggesting there should be something like that? Or, because you've said it has to kind of have our beliefs in it, well, probably the Russians and the Chinese feel differently.
Mm.
So in a sense, if we're a staircase and we're on the second stair, where should we be in 3 years with the kind of ethical part of AI?
So it's a great question. I mean, I don't think you will get a univocal view on all of this from different governments and different kind of jurisdictions. Of course not. What's interesting, I think, about the multilateral discussion that's ongoing now is where they are trying to find a common denominator, a foundation on which they can agree. And just today, there's been an announcement from actually the big tech platforms about a core set of precepts that they would sign up to about keeping an eye out for these major risks, to be being vigilant. So that's to reflect that, yes, there will be differences. There will be different priorities about what people privilege over what other things. I think the precepts here, I say commandments, more like almost a set of proverbs, is more around, if we keep these things in mind, and if we imagine designing our systems to always seek to be transparent and accountable, to always declare their provenance, their origin, then that is a reasonable expectation of the good actors in that space. That won't stop us having to have ways of noticing when people have violated those principles. So I do think that trying to come up with a set of agreed foundation principles is an effort that is worth embarking on. It may be that along the way, what we then do is to say, well, if we want to assure ourselves that these systems do not escape our control, and this isn't about the systems waking up and deciding to put away with us, it's whether we put these things into their own closed loop control, where they are given goals that do not allow human supervision over the top. That would be, in general, a bad idea. People worrying about that, I know, in organisation. Yeah.
Okay, so let's be realistic. How many people in the House of Commons or House of Lords understand this area? Very few. How many civil servants understand this? Very few. So how do we energize the nation? And it's not just us. I mean, this is a profound change, and it's going to be difficult in some ways. Where is your team at Oxford thinking about these big issues, and how will you advise the next government in that sense? Then I'll come on to, there's a couple of questions.
Yeah. So there are any number of ideas being handed down about what AI systems might or could do. That's on the one hand. The other hand, there is this kind of complexity around these artifacts. They are huge. They are huge amounts of energy, huge amounts of expertise to build them, often heavily mathematical objects, hard to understand. One of the things about the earlier generations of AI, in some sense, they were scrutable. You could actually open up the reasoning chain of an expert system and see the rules that had been invoked to get to a conclusion. The fact that you might have a blood infection of a particular type was there in the chain of reasoning. Whereas with deep neural networks, extracting that explanation can be more complex because it's been trained on thousands and thousands of examples. And what's been extracted from the features that those examples provide may or may not correspond to the explicit rules that you have found, but nevertheless, it's a very robust classification system. And understanding where those strengths and opportunities sit and how you can build systems that have elements of both, that is a technical question. But I'd submit, Derek, that we absolutely do have to find ways of boiling this down to areas that at least people have a sense of critical thinking around them. So the latest distribution of generative AI in Microsoft's products, so-called Copilot, many people using this in various ways, whether we've had a way of providing them with a digital literacy to appreciate what the limits are on these systems, what they should be looking out for in terms of potential errors or potential strengths and weaknesses of these systems, is not a form of literacy that is being widely practiced. So in the very same way that at the outset, the dawn of spreadsheets and file systems and databases, there was a sense that we needed basic digital skills, many of which have now just been completely absorbed. And in various ways, we consume our word processors and our databases and our spreadsheets. There's something that we need to be putting together to equip the politician and the citizen and the consumer with an awareness of the strengths and weaknesses and requirements of these systems, whether it's in the data, the way they're processed, the way they account for themselves.
Okay, if we're going to get the questions in, we need slightly pithier answers. I know that's.
I'm sorry, I was trying to give you a fun because I mean it's
no.
question.
Jan Dorman says in his question, is it feasible to have a technocratic oath for AI, a little bit like the Hippocratic oath that we have for the medical community?
I think that's an interesting idea. I think it's much of the work in AI ethics has been inspired by the analog work in medical ethics, that you occasionally need to come up with new concepts, new terms, and perhaps new adherence to sets of principles. Of course, medicine is a licensed profession. We don't have that in computer science. People come from many backgrounds and streams. Of course, there's training, but it's not a licensed profession in that regard. Perhaps in some specific areas, we might wish to move to something that is more licensed. But I think the adoption of principles about the things we seek to promote would be a very good idea.
This is from Malcolm Harbour, sorry, I even know him. How do AI systems accommodate existing notions and applications of intellectual property and copyright? You've got 2 hours on that one.
Yeah, they seem to play fast and loose with it, to be fair. So the issue about what's been harvested from where and how you mark up content so that its terms of use are much more explicitly labeled is precisely now we've got to do some development, because I think people aren't entirely happy with the settled status. Just to give up on copyright and IP protection seems less than ideal.
Okay. Mervyn Hogg must be a musician. How long might it be before we see the AI tools creating performances of classical music to a standard that matches the very best performances of professional musicians and soloists? Is this a reality?
Well, one of my fellows here in Jesus College, Rob Laidlaw, works with AI. He's a composer. He is experimenting with the entanglement of humans and machines in a creative process. The idea that your systems can entirely generate stuff that we find pleasing and entertaining, it'll be a continuum. I think there's something very important about knowing that a work of art has been produced by a human who suffers and feels and dreams and aspires and has practiced hard to produce that artifact. It's the technical excellence is apparent in many of these systems. Whether they have that effective content is an interesting question that people debate.
I hope I get Andrew Rogoski's name correct, but he's asked a number of questions. One of which is there are thousands of statements from governments in every department, even the Vatican, about AI and everything. There's no mechanism to enforce it other than an audit. Is there a better way to achieve it other than an audit?
Well, audits and various forms of assurance, I think there'll be a multi-layered approach. So when I talked about the use of regulators, you can think about the evolution of social norms. You can think about sectors requiring audit. And you can think at the highest level about placing legal restraints on various forms of output and behavior. So I think you're going to have layers of developing approach to this as we see harms and benefits evolve.
Okay, this is really a hard one. This is from Karina Westlin. Do we have any viable hypotheses about how to manage regression to the mean on the open web?
It's
a long question, but it's
a long question, but it's to this issue about model collapse. How do we keep the web full of, in some sense, novel and innovative content? And it's noteworthy that one or two sites have prohibited the inclusion of machine-generated content in their responses, or they're looking to screen it out. And I think that's because precisely this richness at scale needs human participation. And I think there's an interesting question around here about equity and access. There is a huge part of the human population whose created content is not represented on the web at scale. And I think we're going to need humans to keep the web relevant and reflective of human interests.
Okay, this was something, some of us went to the State of the Net in February in Washington, and we learned there that Biden has introduced an executive order on AI. It's very short, pithy, but the argument in it is that over all of Washington and how it works, there should be a privileged position for AI at the top. Now, the way I interpret that for the UK, so tell me if I'm mad, you have a Prime Minister, you have the Chancellor of the Exchequer, and you have the Chancellor of AI, and they sit above. Has there been, or have you come across any think tanks or any work on this area? Where are we going to place it in government?
Yeah. I mean, it's interesting to reflect on this general purpose technology needing to have that sort of oversight. Did we do it with nuclear technology? We had it in place in various of our departmental ministries. We had a network of which has served us quite well in science of chief scientific advisors. But the idea of various supremos, in fact, there is a proposal in the Tony Blair Institute work that there would be a particular location of AI sign-off within the Treasury, for example. What does that look like? How is it managed? Why that? Why is AI different than other digital technologies that have come before? At various points, I think, as this settles down, we may well feel that the impact of AI is such that it does require some form. I mean, is it political guidance? Is it regulatory oversight? Are there various forms of ombudsman for this field? There are different models we need to be looking at to understand. And in the UK, I think our harms-based, our case law approach gives us a framework for thinking about this. If you're going to be proactive in the way you suggest, Well, it's for governments to think. Why Biden has advanced that is because I think he's getting a lot of advice about the primacy of this technology for US economic and other interests. And so that is something perhaps we do need to reflect on. Don't have a clear sense of whether that would work in a UK context. You will probably know better than I.
Well, there'll be a land grab somewhere. This is from Desiree Milosevic Evans. The 5 UN principles of ethical use are different from the 7 EU principles on risk approach. Should AI regulation be based on regulating science or based on legal precedents or both?
Yes. Regulating science. So again, there's been I remember when I was president of the BCS, there was a sincere belief by 1 or 2 of our members that the thing to do was literally stop the clock. You would not allow your processors to become powerful beyond a certain point, because beyond that, problems lay. In fact, almost all of the advances in AI owe huge amounts to the engineering that the people building the computer chips have given us. Just wouldn't be possible to get where we are without fantastic speed ups in power of our computing fabric. So self-limiting the science can be very hard, because it is going to be dual use. This is why putting the values into the education of the people building these systems, why we teach AI ethics courses to our computer scientists, isn't for just because we think they might find it very interesting. It's because we feel they should be embodying it in their practice. So the science needs to be practiced by people who understand a hierarchy of risks, for example, the things to which systems can be put, the checks and balances you need in designing your software. And the question around legal enforcement, there is legal precedents that will be a part of it as we build a canon of cases in which we feel comfortable or very uncomfortable with the ways in which AI is being repurposed. We saw this, for example, in facial biometrics.
Okay, this might have to be the last question, but there are many more that want to ask. This is from, I hope I get his or her name correctly, Kaudi Falana. You know, if you remember, we weren't allowed to take logarithms in, and then we were, and we weren't allowed to take a calculator into exams, and then they were. So this person wants to know whether you think there'll be a time when academic candidates will be allowed to explore both the AI capability of a question and their own one.
Well, I can imagine we're wrestling with that one here in the University of Oxford. So what is the appropriate use of these technologies in evaluating or in the educational process? And there are various areas in which certain sorts of mental effort have been offloaded onto digital devices. The scientific calculator is kind of understood to be an acceptable use. The idea of a conversational agent which could kind of write your essay for you is not exactly where we want to be headed. The question is how we can actually allow these systems to help elicit a better product from the human student, to help them reflect on their reasoning, to help them reflect on the quality of their answers, not for it to be the machine-generated answer. Comparing the two against one another is, to be fair, what a lot of people are doing at the moment. And the sense is that some of the large language model answers are formulaic, they're structured in a particular way. There isn't necessarily the cut and thrust that you might expect to see in a well-tutored undergraduate candidate.
Well, listen, if you haven't got the book, here it is. Just make sure you go out and buy it, everyone. Just before I hand over to Louise, Nigel, thank you so much again. Spectacularly interesting talk. It'll take a while to get underneath it all, but thank you. And now back to Louise.
Thanks, Derek. Thank you.
Okay, thank you. Thank you so much, Nigel, for an absolutely fascinating talk. I think the element that really, the sort of phrases that got to me and I shall remember, is that it all depends on high quality data. And the need for data to be an assured product. And I think I've heard you speaking before about the importance of transparency. And this, that seems vital to me. And I loved your start of the principles. I'm looking forward to reading the book. It should be transparent and accountable to humans. That seems really, really important. I'm sure that I speak for everyone when I say it's been a wonderful talk. And this is an area that we at DPA are going to be talking a lot about in the future. And for anyone who's not a member of DPA, please go to our website, www.dpalliance.org.uk. DPA, for those of you who don't know us, was founded in 1993 and has a long established history of an independent, not-for-profit, cross-party membership organisation that brings parliamentarians, government officials, industry and academic stakeholders together. We try to do that to inform policy and regulation going forward. And we want to help parliamentarians and policymakers to understand the potential impacts, implications, and unintended consequences of their policies and how they interact and leverage online and digital technologies. For those of you who don't know us, at the moment, we're particularly working on the regulation connected with the Online Safety Act, digital identity, levelling up connectivity in the UK, post-quantum computing and security, which is being informed by regular meetings with the NCSC. And of course, as I said, AI. Legislation and regulation in the UK needs to be seen next to that that's going on in America and the EU in particular, and what is happening now with Korea. And in fact, with two of my fellow directors, Derek Wyatt and Malcolm Harbour, being very well informed about what's going on in the US and the EU, we're hoping to have some talks about that in the future. But I think what we will be looking at, and might pull you in again to give us some more ideas on it, are those foundation principles of AI. It's been a fantastic afternoon. Thank you so much for giving us this lecture. I'm sure Harry Renwick would have really appreciated it.
Well, there, we're back.